Okay, so there are several different function families that you will come across in math, but we're going to focus only on four this year. And let those be our focus. And so what we're going to start with is the parent functions. Okay, so we're going to talk about the parent function for each of these. And what that means is that every graph has this one, every family, function family has this one graph that they build off of. So this is the original linear, this is the original exponential graph. And then what happens is we make adjustments and move it around. So any other line that you would ever see is originally starts with this, and then we start making changes to slope and movement and x-intercepts and y-intercepts, and we start kind of adjusting the location of those and the size of those graphs to change them to what we want them to be. And so these are the parent functions that we're going to talk about first. So we're going to talk about linear first. And so remember that linear has a constant rate of change. Okay, it's always going to be constantly changing at the same rate. Domain is always going to be all real numbers. Range is all real numbers. There is no minimum or maximum because it's going to keep going forever in all directions. It will have generally one intercept. It is possible that if you had a horizontal line or a vertical line, it would have zero intercepts, but that's actually a different parent function. That would be called a constant parent function. So, so really it has one intercept. It'll be one x and one y. Symmetry, it does have symmetry. And there is no turning point. It doesn't change direction. It's always going to go in the same direction. Okay, so no turning point on that. The second type is exponential. We won't talk a lot about exponential this year, but there will be a couple of opportunities that we'll use about it. So exponential actually grows at a rate of an exponent, so multiplication, rather than at a constant. So it's not a constant rate of change. The domain is all real numbers, and the range is just going to depend on the location of it and kind of the direction it's going. So range will vary, is what we're going to write. Okay, it'll depend. Minimums and maximums. There are none, no minimum, no maximum. It actually keeps going forever, and it keeps going forever in this direction as well. Intercepts, it may have, again, the location just kind of depends. So 0 or 1 x-intercept and 0 or 1 y-intercept. Could be either way. I'm not sure. Just depends on where it's located on the graph. Symmetry, it has none. And turning point, it also has none. It's always moving in the same direction. Even though there's a curve in it, it's still moving in the same direction. All right, so these are going to go in your notes about parent functions. We have two more, the quadratic. So this shape of a quadratic is called a parabola. P-A-R-A-B-O-L-A. Okay, that's the shape of it. It does not have a constant rate of change. It's actually going to be moving based on multiplication. You're going to be multiplying something. Notice how it's x squared, so we're actually going to be using that exponent idea again. Domain is going to be all real numbers. It's always going to be moving out, whether up or down. It's always going to be moving out left and right. And the range is going to vary. It just depends on the location of it. So this would be, from here up, but if it were flipped in the other direction, or if it were moved over here, or whatever the case may be, it would change. It does have a minimum or maximum, so it has one, and it just depends on which direction. So this would be a minimum, but if it were flipped, it would be a maximum. Intercepts. It will generally have either 0 or 1 x, or it could have 2 x-intercepts, depending again where it's located. Remember, we call those zeros. And that's for all of them. I just didn't think to tell you that or to remind you of that. So you could have 0, 1, or 2 intercepts, x-intercepts. And then y-intercepts is the same thing. You could have 0, actually, you can't have 0 y-intercepts. You can't have 1 y-intercept. I can't think of an opportunity where you would have 2. So 1 y-intercept on this. If you can think of another opportunity, let me know, and I'll be glad to fix that. But I think it's just going to be 1 on that. Symmetry, yes, it has it, and yes, it has a turning point. See, it's going down here, and then it switches and starts moving up. Then we move to absolute value, which is very similar. The difference here is that you have a rounded curve, whereas this is a point, an actual point. So it does have a constant rate of change to the turning point. And then it becomes constant but opposite. So it's still constant even after it switches, but it just becomes the opposite. It's going the opposite direction. Domain, it's always going to be all real numbers, and the range is just going to depend on where it's located. And then a minimum and a maximum, it will have 1. Intercepts, it will have possibly 0, 1, or 2 x-intercepts. And as far as the y-intercepts, probably just 1 y-intercept. And then symmetry, yes, it has it, and yes, it has 1 turning point. So make sure you get that copied down in your notes, and we'll go from there.